Welcome to This Explainer. Today, we're diving into the astonishing, almost unbelievable dual legacy of one of history's most fascinating minds. We're talking about a figure whose name is recognized all over the globe. Yet, the person most of us think we know is kind of just a shadow, or honestly, an invention, hiding a much more profound reality. The moving finger writes, and having writ, moves on. You've probably heard those famous words. You likely know him as the romantic, wine-loving Persian poet who penned them, popularized in the West. It's a gorgeous verse about the relentless passage of time for sure. But what if I told you that poetry was essentially just his side hustle? That his true genius lay in completely different fields? So here's the roadmap for today. We'll look at the tent maker of Nishapur, solving the unsolvable, reforming the heavens, the translation controversy, and finally, a monumental synthesis. Section 1. The tent maker of Nishapur and his life in the Seljuk Empire. Let's wind the clock back to the 11th century. We're talking about a time of immense political upheaval. Born in 1048 in Nishapur, a major cultural hub in what's now northeastern Iran, his name, Khayyam, literally translates to tent maker. It probably referred to his dad's trade. But young Omar, he grew up to stitch together the very fabric of science, all while navigating the incredibly volatile Seljuk Empire. The Seljuk Turks had just invaded and set up this really unstable military state, so it wasn't exactly an easy time to be a scholar. He even complained about the lack of support for true scientific pursuits back then. Yet, despite all of that, he literally pushed human knowledge forward. Moving on to Section 2, solving the unsolvable, groundbreaking mathematics. Because really, his true day job was revolutionary mathematics. He actually wrote, "Whoever thinks algebra is a trick in obtaining unknowns has thought it in vain." He saw the deep, physical truth behind numbers. He didn't view math as just moving abstract symbols around a page. To him, it was a profound expression of geometric reality. Around the year 1070, he put together his landmark treatise on demonstration of problems of algebra. And here's his most mind-blowing mathematical achievement. Before Khayyam, finding general solutions to cubic equations, where variable is cubed to the power of 3, was considered ridiculously difficult, if not totally impossible. He didn't have access to negative numbers, so he couldn't just use modern algebraic formulas. Instead, centuries before modern algebra was even a thing, he came up with this brilliant visual method. He literally translated the algebra into geometry. By drawing intersecting conic sections, specifically overlapping a parabola and a circle, he could pinpoint the exact point of intersection, and boom, that physical point gave him the root, the solution to the cubic equation. It's just an incredibly elegant synthesis of algebra and geometry. But his genius didn't stop there. While he was working on commentaries about the ancient Greek mathematician Euclid, specifically trying to prove Euclid's infamous parallel postulate, Khayyam accidentally proved properties of figures in entirely new geometries. He was really just trying to validate the existing rules of flat 2D planes, but his rigorous logic inadvertently opened the door to non-Euclidean geometry, a field that wouldn't even be formally recognized for another 700 years. No way, right? Section 3. Reforming the heavens, the Isfahan Observatory. So by 1074, his absolute mastery of earthly geometry catches the eye of the Seljuk Sultan, who hands him a massive task, reforming the calendar. And the result? Consider this jaw-dropping number, 365.242198585156. That is the exact length of the solar year in days that Khayyam and his team at the Isfahan Observatory calculated. The level of precision here is just off the charts, especially when you remember they achieved this without modern telescopes or computers. To understand how insanely accurate this is, the length of the solar year actually shifts in the 6th decimal place over a single human lifetime. To really put his calculation into perspective, let's compare it to the modern era. The calendar he helped design, the Jalali Calendar, has an error of just one day every 5,000 years. The Gregorian calendar, the Western one we all use today, introduced 5 centuries after Khayyam, is off by one day every 3,333 years. Think about that. Khayyam's 11th century calendar is significantly more accurate than the one we use today. In fact, the modern Iranian calendar is still based on his incredible foundation. All right, Section 4, the translation controversy, creating the hedonist. So you're probably wondering, how did this super disciplined, meticulous mathematical genius become known globally as a hedonistic, wine-obsessed poet? Well, there's an old Italian saying, traduttori traditori, translators are traitors. Enter Edward Fitzgerald, a Victorian English writer. In 1859, he published a translation of a collection of Khayyam's four-line poems, the Rubaiyat. But Fitzgerald freely admitted his work wasn't a literal translation. He called it a transmogrification, claiming it was better to have a live sparrow than a stuffed eagle. This interpretation completely remade Khayyam's identity for the Western world. The original Persian verses were deeply philosophical, highly disciplined, and sometimes pretty pessimistic, contemplating the vast universe and the fleeting nature of life. But Fitzgerald? He crafted this party-loving, anti-Sufi Victorian persona that was basically crying for wine, wine, wine. He essentially wrote his own Victorian poetry loosely sprinkled with Persian allusions. As Jorge Luis Borges noted, Fitzgerald and Khayyam essentially merged into a single poet through this wild literary twist of fate. And this version took the world by storm, selling millions of copies and forever branding the master mathematician as a hedonistic bard. Finally, Section 5, a monumental synthesis, the mausoleum at Nishapur. But thankfully, in modern Iran, Khayyam's true, multifaceted legacy has been beautifully reclaimed in stone. Back in 1112, he actually prophesied that his grave would be where flowers in the springtime would shed their petals over his dust. Sure enough, 4 years after he died in 1131, a pupil visited his grave and found it hidden beneath a blanket of fallen peach and pear blossoms. Fulfilling that exact legacy, a stunning modern mausoleum was erected right over his resting place in Nishapur in 1963. And what's truly brilliant is how the architecture itself tells his real story. Designed by the Iranian architect Hushang Sehun, every angle of this white marble masterpiece physically synthesizes Khayyam's diverse brilliance. The complex, intersecting geometric patterns perfectly honor his work in algebra and cubic equations. The soaring star-like dome reflects his time staring into the cosmos as an astronomer. And it's all nestled within walled gardens, ensuring those spring flowers keep falling, celebrating the poetry that made him immortal. It's a single, lasting monument to a brilliant polymath. Which leaves us with a really fascinating final thought to ponder. Because of Fitzgerald's highly inaccurate translation, Omar Khayyam became a global household name. If not for that treasonous translation, his groundbreaking science might have just remained an obscure footnote for everyone except dedicated math historians. So I leave you with this. Is it better to be remembered accurately or to be remembered forever? Thank you for joining me on this explainer, and keep questioning the history you think you know.